Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to discuss one example problem 1.21. In our previous video we discussed about effects of dielectrics in capacitors. Based on the concept, this problem is given. A parallel plate capacitor filled with mica having epsilon r is equal to 5 is connected to a 10 volt battery. The area of the parallel plate is 6 meters square and the separation distance is 6 millimeter. Find the capacitance and stored charge. Let us discuss a part alone. What is given? Epsilon r is given, that is 5. V is given, that is 10 volt battery. Then area A is equal to 6 meters square. Then separation means D is equal to 6 millimeter. You convert this millimeter into meter, so 6 into 10 to the power of minus 3 meter. So you have to calculate the capacitance of the capacitor. So the capacitance of the capacitor C is equal to epsilon A by D. This is the general formula. You know that epsilon r is equal to epsilon by epsilon naught. Suppose I need epsilon means you can write it as epsilon r into epsilon naught. So epsilon r, epsilon naught A by D. So epsilon r is given, that is 5 into epsilon naught value, you know, 8.85 into 10 to the power of minus 12. A value is given, that is 6 meters square. Then D value is given, 6 into 10 to the power of minus 3 meter. So cancel the 6. So multiply these two. You can get the value as 44.25 into, bring this 10 to the power of minus 3 to numerator, so it becomes plus. Finally you can get minus 9. Or we can write 44.25 into 25 nanofarad. Next we are going to calculate charge. Charge formula Q is equal to CV. C value you know, that is 44.25 into 10 to the power of minus 9. V value is 10 here, so 10. 442.5 into to the power of minus 9. Charge unit is coulomb. Or we can write 442.5 nano coulomb. U is equal to half CV square, half C value you know, that is 44.25 into 10 to the power of minus 9, so 10 square. So cancel this 2.125. So 22.125 into 10 to the power of, here minus 9, here plus 2. So minus 7 joule. Or we can write 2.21 into 10 to the power of minus 6 joule, or 0.21 microjoule. This is U value. So first subdivision over. Then B subdivision. After the capacitor is fully charged, the battery is disconnected. So battery is disconnected, dielectric is removed carefully. Calculate the new values of capacitance, stored energy and charge. Here Q remains constant. Potential is increased. Potential is increased means capacitance is decreased. How did I say? C is decreased. C is equal to Q by V formula. So V increases means capacitance C increases. Both are inversely proportional to each other. So in this scenario, Q constant, V is increased, C decreased. The capacitance C naught epsilon r. C value you know, epsilon r you know. So calculate C naught. C naught means C by epsilon r. C, what is C? C is 44.25 into 10 to the power of minus 9. divided by epsilon r is nothing but 5. Cancel this. So 8.85 into 10 to the power of minus 9 farad, or we can write 8.85 nanofarad. So stored energy U0 is equal to epsilon r into U. Here epsilon r is 5, U value you know 2.21 microjoule, that is 10 to the power of minus 6 joule. So multiply these two, you can get 5, 0, 11. 11.05 into 10 to the power of minus 6 joule. This is our U0 value. How do you calculate increased energy? Initial energy is U0, that is 11.05 into 10 to the power of minus 6. Final energy is U, that is 2.21 into 10 to the power of minus 6. So your answer is 11.05, 2.21. So 4, 8, 8. So 8.84 into 10 to the power of minus 6 joule. Delta U is equal to 8.84 into 10 to the power of minus 6 joule, or we can write 8.84 microjoule. This is your delta U value. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.